Hello all, this is Mr. G, and after this video we should be able to simplify powers of I. Still working in chapter 4, section 8, moving along in this final final section of chapter 8. Now we're dealing with what we're calling powers of I. But before we get into what that actually means, what it looks like, let's sort of bring the information from yesterday's lesson, or yesterday's video, the last video rather, back to the front of our brain. So what's the most important thing to remember about I? If you want to pause the video right now and think, or look back in your notes, that's fine. But there's a lot of important things about I. But I think one thing stands above them all. Like you could say, well, it's important to know that I is not a variable. Like usually when we see a letter like X or Y, it's a variable, but I is not a variable. I is a number, specifically a non-real number. Now, some people might say the most important thing is to remember that I equals the square root of -1. But I disagree. I think this is a close second right here. But I think the most important thing is to remember that I squared equals -1. If you're only going to remember one thing about I, that's the most important thing to remember. I squared equals -1 because everything we're going to base, really all of our lessons about non-real numbers, is based off of this fact that I squared equals -1. So like I said in the objective, today we're talking about powers of I. And powers of I actually work differently than you might expect. Like a lot of, let me add a slide. Let me go back here. Like a lot of people think like, oh, it'll just be like x squared. Okay, so that's just x squared. X to the fourth power, that's just x to the fourth power. Here, there's nothing to simplify. But remember, I is not a variable. I is a number. It's a non-real number. But when we have a number to a power, we have to simplify it. Like for example, if I give you 3 squared, you wouldn't just leave that as 3 squared. You would say, oh, that's 3 times 3, and that's 9. You would simplify the expression. But simplifying powers of I, it just takes some practice. So let's not waste any more time. Let's jump right in. So powers of I. We've got a table here that we're going to complete, and there's one that's hiding behind my face, but we'll get to that one in a second. So we're going to start with I to the first power. Now, I to the first power, well, anything to the first power is just itself. So that's just going to equal I. That one's not too bad. Moving right along, now we're going to look at the next power of I. So we went from I to the first, now we're going to look at I to the second power, essentially adding one I. Or not adding one I, multiplying an additional I in. That would be a better way to say it. So I squared, well, what's I squared equal? That's the most important thing you need to know. Remember, we talked about that back on this slide. I squared equals -1. Got to know it. So we can add that to our table. I squared equals -1. Then we get to our next power of I, which is I to the third. Again, we're just multiplying in an additional I. We started with I, then I squared, which is I times I. Now I to the third, I times I times I. Now I'm going to rewrite this. I'm going to rewrite this as I times something. Or rather, let me restate that again. I to some power times I to some power. Essentially, I'm going to break this I to the third up into two factors. I to the something times I to the something. The question is, what could those powers be? What I would do is I would say it's I to the second power times I to the first power. Now, let me be very clear about where I'm getting these. Basically, those two powers I picked, the 2 and the 1, can be anything that add up to this 3. Because when we're multiplying common bases, we add the powers. So I squared times I to the first, that's the same thing as I to the 2 plus 1, which gets us back to I to the third. So we haven't changed anything by rewriting this I to the third as I squared times I to the first. But now we can sort of substitute in, or rather simplify, these two expressions, the I squared and the I to the first, because we already know what they equal. We know what I squared and I to the first equal. So I squared, that's just going to be -1, getting that fact from right there. And then that's going to be times I to the first, well, that's just I. And now we are in a position to say, okay, what does I to the third actually equal in its most simplest form, or in simplest form, I should say, and that's -1 times I. Well, -1 times anything is just that thing negative, so -I. I to the third equals -I. All right, moving right along. Now we're going to look at the next power. So we did I to the third, multiply one more I in, gets us I to the fourth, and we're going to approach it the same way. Break it up into I to the something times I to the something. The question is just, what are those powers going to be? Now, there's a few different ways to do this. Personally, I would break this up as I squared times I squared, because 2 plus 2 would get us back to that power of 4. And we know what I squared equals. I squared is -1, so this is going to be -1 times, well, I squared again is going to be -1. So we get -1 times -1 is a +1. So that's actually kind of weird because we started with an imaginary number over here, but when we simplified it, oh, excuse me, let me move this one. That's what I wanted to move. We had an I, but when we raised it to the fourth power, we got a one. We got a real number. I guess that shouldn't surprise us too much, though, because the whole basis of this imaginary number is when we square it, we get a negative one. We get a real number. All right, so let's see what happens on this next column. So let's keep moving on. Now we got I to the fifth power. Again, going to break it up. I to the something times I to the something. Again, the higher we go with our powers, the more options we're going to have to break it up. So the way I'm going to show you is not the only way to do it. I would probably do I to the fourth times I to the one. I think that's how I would do it. And then we can look back at our table. I to the fourth, we know that equals one. So it's going to be 1 times I to the first. Well, we just look back here. That's I, because anything to the first power is itself. And 1 times I, well, that's just I. So I to the fifth, we got I or I to the first power. That's another way we could say it. Okay, let's keep on going. I to the sixth. Again, just multiplying in another I. Let's break this 6 up. How can I break it up? I would probably go I to the fourth times I squared. And then I to the fourth, that would be 1 times I squared. That's negative 1. Again, we're just getting these numbers back from this original column that we filled in. And well, 1 times negative 1, that's just negative 1. All right, let's multiply another I in for I to the seventh. Again, hopefully you're seeing the pattern by now. We're just breaking up I to the something times I to the something. To get to a 7, we could do 4 plus 3. Again, that's not the only way to do it, but that's the way I would do it. And I to the fourth, we know that's 1. Back from that part of the first column. Oh, yeah, that's what I wanted to undo. Seriously. Let me just do this. And get rid of that. Come on. Got to have this look nice. What was it? I to the fourth, that's 1. Times I to the third. Again, we can look back in the first column. We see that's a negative I. So 1 times negative I, well, that's just negative I. All right. Now, okay, let's look at I to the eighth. So I to the eighth, it's I to the something times I to the something. To get to 8, I would do 4 plus 4, I guess. I to the fourth times I to the fourth. Then simplify that. I to the fourth, we know that is 1 times, I to the fourth again is just 1. And 1 times 1 is 1. Now at this point, if you were thinking, man, if we have to do this whole table for every power of I, this is going to get real old real fast. And I wouldn't blame you. But I'm also hoping you're noticing a pattern here. Let's take a look at this. So we had I, then negative 1, then negative I, then 1. Then we had I, negative 1, negative I, 1. Those fourth numbers sound real familiar because they're the same as they're the same as the first column, which means this I to the ninth, if it follows the pattern, will just be I. I to the 10th will just be negative 1. I to the 11th will be negative I, and I to the 12th, if I move my face out of the way, will be a 1. So essentially we get the same 4 answers over and over and over again in this cycle. And really that comes from this I to the fourth being equal to 1. Because if you notice, I broke up, or rather I factored everything in that second column. Okay, I to the fourth times something. And if you notice, we got, okay, I to the first, we saw that right there. I to the second, saw it right there. I to the third, showed up there. And I to the fourth, showed up there. So by factoring out that I to the fourth, we essentially took the second column and moved it back so it matched the first column. So really, we only need to know 4 powers of I, and they're the first 4, right here. I to the 1 equals I squared equals negative 1, I to the third equals negative I to the fourth equals 1, and then the cycle just repeats. It goes on and like that all the way we could have as high a power of I as we want. It's just going to be one of these 4 numbers repeated over and over again. Now, I'll be honest with you. I don't always have these memorized. The most important one, the only one I really always have memorized is this one right here. I squared equals negative 1. Because if I know I squared equals negative 1, as long as I have that memorized, I can build the rest of the table sort of around that. I can get to I to the third equals negative I. I can get to I to the fourth equals 1. Just by breaking, okay, I to the third, that's I squared times I to the fourth, that's I squared times I squared. So as long as you know this one right here, you'll be good. Now I've got a 1 equals down here that you might have noticed. And I want to talk about what powers of I equal 1. Well, the first one is right there, I to the fourth. But that was not the only one we saw on the last slide. What was the next one? So we had I to the fourth, then it was I to the eighth, then it was I to the 12th. Then the next one after that would be well, that would be I to the 16th, and it would keep on going. So what's going on with these powers? We've got a 4, an 8, a 12, and a 16. Hopefully you're noticing that all these powers are multiples of 4. They're multiples of 4, which is actually really critical. So that tells us that anytime we have an I, our imaginary unit, raised to a power, and if that power, that exponent, is a multiple of 4, it's going to equal 1. That's absolutely critical. Anytime we have I raised to a multiple of 4, raised to an exponent, a power rather, that is a multiple of 4, it's going to equal 1. And that's what lets us simplify these big powers like we're going to see in example 1. So we've got I to the 45th, and we'll get to the other two in a second. So I to the 45th. Now at this point, some of you might be thinking, wait a minute, so you're telling me we've got to do this table all the way up to 45? No, absolutely not. What I'm going to do is sort of similar to what we did in the table when we were first talking about the powers of I. We're going to break this up into I to the something times I to the something. But we want to be very, very careful about what that first power is. We're always looking for a multiple of 4. I guess that's not the only way to do it, but I really think that's the easiest way to do it. And we don't just want any multiple of 4. We want the highest possible multiple of 4 that is smaller than the power we're trying to get to. We're trying to get to a power of 45. So the biggest power, or excuse me, the biggest number that's less than 45, but still a multiple of 4, would be 44. So we know it's going to be I to the 44 times I to the something. And that something is going to be whatever adds with 44 to get back to the 45. So it's got to be a power of 1. And again, we can check ourselves. 44 plus 1 gets us to this 45. So far we've kept everything equal. We've kept everything the same. But now this is going to be so much easier to simplify because of this. We've got I to the 44th. We have I raised to a multiple of 4, raised to a power that is a multiple of 1, multiple of 4, which means I to the 44 equals 1. Times, well, I to the 1 is just I, so we get I as our final answer. So one thing, whenever we're simplifying, we never ever want to have a power of I. I guess we can have a power of 1, but that's not really a very interesting power. Anytime we have a power of I that's higher than 1, we've got to simplify it. We've got to simplify it to either that 1, the I, -1, negative I, or 1. I think I said them in the right order. Now we've got them written down, whatever. Okay, enough of my talking. Let's take a look at the next one. I to the 103. We're going to start this just like we did our pattern. We're going to break it up, or just like we did our table, We're going to break it up into I to the something times I to the something. But remember, we're looking for not just any number, but a multiple of 4 that is less than 103. And let's say you're having trouble with that. Let's say you're having trouble. Let me show you how you can use a calculator to help. Just do 103 divide by 4. Okay, we got a decimal, so that's not a multiple of 4. So now we try one less. 102 divided by 4. Still a decimal, no good. Try one less. 101 divided by 4. Still no good. It's a decimal. Okay, now 100 divided by 4. Oh, we get 25. So that means that 100 that we tried is a multiple of 4. So we're going to break it up into I to the 100 times, let me move that, times I to the, it's got to be 3. Because remember, it's got to add up to this 103 that we started with. So if you don't need to use the calculator, that's great. I just wanted to show you a method that will always get you to a multiple of 4 if you ever don't see it. Well, let's see. Well, I to the 100, I to the power of 100, that's going to be I to a multiple of 4, so that's 1. Times I to the third, that's one of the ones we need to know. If you need to look back at your chart, look back at your chart, but I to the third is negative I. So it's going to be 1 times negative I, which is just negative I. And we're finished. Take a look at the last one for this slide. I to the 28. Now you might be tempted, okay, I'm going to start the same way. I to the something times I to the something, but you actually don't need to do that because this 28 already is a multiple of 4. So that means our answer is going to be a 1, and we're done. But let's say you didn't see that. Let's say you looked for a multiple of 4 that was smaller than 28. You'll still get the right answer. Let me show you how you can do that. Well, the multiple of 4 that's smaller than 28 would be 24. So that's I to the 24, which leaves 4 powers left to get to back to this 28. 24 plus 4 gets us to 28. And then I to the 24th, well, that's a multiple of 4. Well, the power is a multiple of 4, so it's a 1 times I to the 4th. That's one we have memorized. That's 1. And then we get 1 times 1 equals 1. We get to our same answer. So even if you don't recognize that 28 is a multiple of 4 right off the bat, you can still get the correct answer. It'll take you a little bit longer, but you'll still get to it. All right. I want you to try example 2 on your own. So try these 2 problems on your own. Pause the video right here. Come back when you think you have your answers. We're going over 3, 2, 1. Let's roll. So I to the 14th, let's see. 14 is not a multiple of 4. So I would break this up into a multiple of 4 would be 12. And that leaves 2 powers left. 12 plus 2 gets us to 14. I to the 12th, since that power of 12 is a multiple of 4, it equals 1. Times I squared, that's the most important one we need to know. I squared equals negative 1. So we get negative 1 as our answer. And then I to the 36. 36 is a multiple of 4, right? Yeah, that's 9 times 4. So that's just 1, and we're finished. That's it. So those are the 2 answers. Hopefully you've gotten correct. If not, just go back, check your work, see what you did wrong. And here is your assignment for this lesson. So your homework, I just want you to do these 4 problems. Simplify each of these expressions. Remember, anytime you have I to a power, you need to simplify it. You don't want to have I squared or I to the third or anything like that in your final answer. Well, that's it for this video. Hopefully it all made sense. If you have questions, let me know. Enjoy the rest of your day.